All right, points, lines, and planes, day 2. Starting with opposite rays. Yesterday we learned what a ray is. Does anyone remember? Yes.
Like an arrow pointing one direction, but the other side is not.
Yes, the other side has an endpoint, and then one side keeps going. So opposite rays, make sure you're writing down, is a pair of rays. What does a pair mean? Two. With a common endpoint, so they have to have the same endpoint. That form a line. Okay. A pair of rays with a common endpoint that form a line. So, if I want to start a ray here, what's the common endpoint here? It would have to be what?
C.
C. And if I go this way, that's B and A. Okay? And yesterday we learned, if you were not here, we learned that when we write the name of a ray, it always has to point which way?
Right.
To the right. Even though this ray clearly is going to the left, when you write the name, we point it to the right in the label. And then what point goes first? What point goes first in the name? C. The end point always goes first. And what does the other point have to be? A or B?
B.
Does it matter?
No.
Doesn't matter. It could be A or B as long as it goes that way. So I'm just going to do B for now. So ray CB, and then if I do another ray starting at C again and go this way, so another C and then D. So ray CB and ray CD are considered opposite rays. The only thing you need to know about opposite rays is that they cannot overlap. They have to share the same endpoint. So put a little remark here. Do not overlap. Okay. All right. Everybody comfortable with opposite rays? Yes. Naming rays? You did it on your warm-up. Are you comfortable with that? Okay, you need to come to math time. Okay, the next part of the notes, we have 5 postulates. What is a postulate? Does anybody know? No? A postulate is a basic true statement that is accepted, okay? And we have a lot of those in geometry. And so a long time ago, a mathematician wrote them down, and then now we have them. So, very important that you number them. So this is postulate number 1. Okay? Postulate number 1 states that if 2 points are on a plane, then, before I keep going, what did 2 points create?
Line segment.
A line. Okay? Any 2 points in space create a line. So, that kind of goes with this. If 2 points are on a plane, then so is the line containing them. Which, if you're in this class, you should already know that, right? With 2 points, you can create a line. Now, here's another challenging question. Does that mean there's only 2 points on a line? No. How many points are on any line?
Infinite.
Infinite. And then if you have a line segment, part of a line, there's 2 endpoints, but then there's
Still infinite in between them.
Yeah, in between them, there's
So that
still.
infinity is less than the other infinity.
Right. Because it starts and ends somewhere.
Yeah. So infinity is less than infinity. But it's also greater than
All right. Everybody okay with that postulate? You understand it? Postulate number 1. If there's 2 points on a plane, then the line that contains them is also on the plane. Okay? All right. Let's look at this side. 3 ways that a line and plane intersect.
Okay.
I'm going to kick you off this table. Number 1, a line passes through a plane, then that intersection is a point. And I know you don't have this in color on your paper, but which colored line is that intersection where it goes through the plane?
Red.
Red, yes, that's number 1. So label it here. Scenario number 2. The line lies on the plane. This intersection is a line. Which line is that? Green. It is on the plane. That's number 2. Okay. And then scenario 3 is the line is parallel to the plane. What does parallel mean?
It never touches.
Never touches. So do they even intersect if they never touch?
No.
No, so there's no common points at all. Yes, and those are the blue arrows. So we have number 3 and number 3. Okay. Okay, let's move on to postulate 2. Open your foldable. Can I move forward?
It's okay.
All right, based on the image for postulate 2, what do you think we're intersecting here? 2 lines. And where do those lines intersect?
In the middle.
Uh-huh. What is that called?
The point.
Point. So this is postulate number 2. Please write the number. Postulate number 2 says that if 2 lines intersect, comma, then they intersect at exactly one what?
Point.
Point. The reason we have to write everything so formally is because it's a postulate. So that's the only reason why we have to write it. I'm trying to abbreviate as much as I can. But
Thank you, Miss.
yeah, if 2 lines intersect, then they intersect at exactly 1 point. Okay, and then just 2 little notes about lines. All lines are what?
Infinite.
Try again. That's true, but that's not what I want to say. It's more simple than that.
Perpendicular.
2 points.
You're close.
Perpendicular?
No. All lines are straight.
Oh.
But since all lines are straight, then we can say that if it is curved, it is not a line. Okay. And this is the kind of route we're going to be taking very soon when we do logic. Proving things that is true or not true. Okay. So can you say that a point makes a line? No. How many points make a line? 2. So you would say false. 2 points make a line. Okay. Alright. Postulate number 2 is done. 2 lines intersect at a point. We're good? Okay. Postulate number 3. What's intersecting here? What 2 shapes? We learned this vocab yesterday. It's a flat surface. What is that?
A plane.
A plane. So, when two planes intersect, where are they intersecting? A line. Good job. So, if two planes intersect, comma, then they intersect at exactly one, what? No.
Two. No, a line.
At exactly one line. Okay. All right, let me use my spinning wheel. Let's call on someone. Sarai. Sarai, can you give me the name of the vertical plane here? The one that's vertical? Based on the picture. Yeah. How will we name it?
How would we name it?
Yeah. Plane.
Q.
Good. Plane Q. And then what's the name of the horizontal plane?
Plane B.
Good. Plane Q and plane B. Thank you. Intersect at Rodrigo. Rodrigo, were you here yesterday? Okay. Can you give me the line, the name of the line where they intersect? Yeah. So they're intersecting here, right? How would we name that line? XY. Good. Angelina. Angie, can you tell me why this is wrong? What did I forget?
The dash on top.
Yes, the line at the top. Don't forget the line at the top, otherwise it is wrong. And that will be on your quiz Friday, okay?
No.
Yes, why do I put arrows?
Because that's the line.
It's a line.
Wait, is this the line? The only line is the line segment?
Yeah, but any 2 points make a line, so it's a line. If it was cut off, then they wouldn't put the arrows. Yeah. The picture will always tell you. So if you see arrows, it's a line. Yeah. Good job. All right, everybody comfortable with postulate 3 where two planes intersect at one line?
Yes, ma'am.
Yes? All right, let's have two more. Postulate 4. What do you think this postulate is based on the picture?
A line segment.
The what?
A line.
Use the math word. Don't use say dots. What do 2 points make?
A line.
So what do you think postulate 4 is?
Line.
2
Line
points
segment.
away.
Line.
Be more formal.
2 points. No.
If 2 points intersect, then they intersect.
Through any 2 points. Did you draw your line? Make sure you draw the line. Through any 2 points, there is exactly one what? Line. And y'all told me this at the beginning of class, so you already knew this one. Good job. Through any 2 points, there is exactly one line. Okay. And since these points are on the same line, what does that make them? What's that vocabulary word we learned yesterday? On the same line, what is it? What vocab word? Do you remember?
Line segment.
No. Collinear. Good job. We learned that word yesterday. What does collinear mean again?
2 points on the same line.
Points on the same line. Good. All right, last one. Postulate number 5. Are we done with 4? All right, postulate number 5. What do you think postulate number 5 is about based on the image? What is this image of? Use the vocabulary terms we learned yesterday. This image has points, right? It has planes. Does it have lines?
Yes.
Are you sure it has lines? Do you see arrows?
No.
Line segments. Okay. So this postulate is about planes through any 3 non-collinear points there's exactly one what? Through any 3 non-collinear points, there is exactly one plane. And that is the reason why when you name a plane, what kind of points do you need? Non-collinear points. Okay. All right. And then one new word, any 3 points are coplanar. That is a new word, so let's talk about it. If collinear means points on the same line, what does coplanar mean?
Points on the same plane.
Good, on the same plane. On the same plane. Okay, write that down so you don't forget. Coplanar. All right, let me see the wheel. Rodrigo. Rodrigo, you got picked again. Rodrigo, can you tell me, are points G and D coplanar? Are they on the same plane? D and G, this one, and this one. No, they're not. How many planes is there actually on this figure?
5.
Try again.
2.
6. Good. All right.
Keep it 5.
Evan, are points A and G coplanar? Yes. Good job. Sarai, are points J and B coplanar? Are they on the same plane? The same flat surface? No, they're not. Good. Good job.